Hello my dear students, welcome back in the lecture series on project management techniques in the subject of management science or operations research. In today's video we would discuss about the procedure of calculating floats or slacks for different activities that are performed to complete a project. In the previous videos of this lecture series we have discussed how to draw a network for the given activities of a particular project, and then we have calculated the earliest start and earliest finish times for different activities, and then we have calculated the latest start and latest finish times for different activities. And in the end, on the basis of all of this information, we have calculated or identified the critical path of the network. So in this video we would discuss about the different floats for different activities of the project. First of all, we need to understand the concept or meaning of the float or slack. Basically, floats represent the postponement or delaying of the non-critical activities without affecting the duration of the project in question. In other words, we can say that floats depict the amount of time by which project activities can be delayed without affecting the time period of the project or the duration of the project. Generally, the floats are the parameters of the flexibility in earliest and latest starting and finishing times of the activities. So, in its simplest form, a float shows the amount of time by which a particular activity can be delayed without affecting the duration of the overall project. There are different types of floats that we will discuss in this video. These are total float, free float, interfering float, and the independent float. So let's start with the concept of total float. Total float of an activity represents the amount of free time that is associated with it. Or in other words, we can say that total float of an activity depicts the amount of time by which it can be delayed without affecting the duration of the project. So the basic concept is that the duration of the project should not be compromised by delaying different activities. There are different methods to calculate the total float of a given activity. Some of these are, the first one is that total float can be calculated by finding the difference between total time available to perform an activity minus the duration of that particular activity. Total time available to perform a particular activity can be calculated by using this expression, that is latest finish of that activity minus the earliest start of that activity. So by using this expression we can calculate the total time available to perform a particular activity, and then we can reduce from it the duration of the activity to find the total float of for that particular activity. In addition to these expressions, we can use or we can find the difference between latest finish time of that activity and the earliest finish time of that activity, and in this way we can calculate the total float. Further, we can also use the difference between latest start time and earliest start time to find the total float of the activity. So let's have an illustration to find or to calculate the total float for different activities which are given in this network. So let's start with the activity D. For activity D we need to calculate the total float, and these are the different expressions or formulas that we can use to calculate the total float. So let's use the first expression, that is total time available minus duration of the activity. So total time available for performing activity D, activity D can be calculated by using this expression, that is latest finish minus earliest start. So for activity D, the latest finish is 14 and the earliest start is 2. So the duration for activity D, so the time available to complete this activity would be equal to 14 minus 2, that is equal to 12 days. So activity D can be performed in 12 days, and in 12 days time period. So the total time available to perform activity D is 14 minus 2, that is equal to 12 days. After that we can calculate total float easily for activity D, and the formula is total time available minus duration of the activity. So total time available is 12 days minus duration of the activity, that is 3 days. 3 days. So total float for activity D would be 12 minus 3, that is equal to 9 days. We can calculate total float by using other expressions, that is latest finish time minus earliest finish time. So latest finish is 14 days and earliest finish time is 5 days. So the difference is 9 again. So the same value we get after applying the third formula. And the fourth one is latest start time minus earliest start time. So latest start is 11 and the earliest start is 2. So again the difference would be equal to 9. So by using these formulas or expressions, we can calculate total float for activity D. In a similar manner, we can calculate the total float for other activities. Like for activity G, the total time available would be equal to 16 minus 11, that is total time available would be equal to latest finish, that is 16, minus the earliest start, that is 7. So total time available would be equal to 9 days. So out of 9 we need to reduce the duration of the activity, that is 4. So the total float available with activity D would be equal to 9 minus 4, that is 5 days. So similar procedure we can apply on other activities as well to calculate the total float for them. Now we will discuss the concept of free float. Free float is that part of total float of an activity which can be used without affecting the floats of the following activities or the successor activities. In other words, free float of an activity depicts the amount of time by which it can be delayed without affecting the earliest starting time of the succeeding activities or the following activities. It can be calculated by using the following expression, that is total float minus head slack. Head basically denotes the head event of the given activity, and head slack can be calculated for the following activity by using these expressions. Either we can use the difference of latest start and earliest start, or we can use the difference of latest finish and earliest finish. So let's understand the concept of free float with the help of a practical illustration or with the help of an example. So the concept of free float is that by delaying activity D, again we are taking activity D, by delaying activity D, we are not affecting the activity I, that is the following activity of activity D. Suppose if we delay activity D by 5 days, then the starting point of activity D or starting day for activity D would be 7th day. So if we are starting activity D on 7th day instead of 2nd day, then the finishing time would be equal to 7 plus 3, that is 10th day. On 10th day the activity D would be completed. If instead of 7th day we are starting activity D on 8th day, then the finishing day for activity D would be 11th day. 8 plus 3, that would be 11. Similarly, if we start activity D on 10th day instead of 2nd day, then the starting point would be 10 and the ending or the finishing time for activity D would be equal to 13. So again we are not affecting the starting point for activity I. But if after 10th day, if we are starting activity on 11th day, then the finishing time for activity D would be 14th day. In that case we are affecting activity I, or we are affecting the earliest starting time for activity I, because activity I can start only after completion of activity D. If activity D is finishing or is completed on 14th day, then the starting or earliest start for activity I would be the 14th day. So it means we are delaying activity I by delaying activity D. So the free float represents that part of the total float which do not affect the successor or the following activity, or the earliest start of the following activity. So let's find the free float for activity D. So we can use this formula to calculate the free float for activity D, that is total float minus head slack. So head slack basically denotes the following activity. We calculate head slack for following activity, and that is I. So head slack can be calculated by using this expression ls minus es, that is latest start minus earliest start. It would be 16 minus 15, that is equal to 1. Again, if we use the another expression, that is latest finish minus earliest finish, or latest start minus earliest start, that is 14 minus 13, again it would be equal to 1. So the head slack, the value of head slack is 1, and the value of total float for activity D that we have calculated in earlier case is equal to 9 days. So the difference of total float and head slack would be equal to 9 minus 1, that is 8. So the free float available with activity D is equal to 8 days. So if we delay activity D by 8 days, even in that case we are not affecting activity I, or we are not affecting the earliest start of activity I. But if we are delaying activity D by more than 8 days, in that case we would affect the earliest start of activity I. Suppose if we are delaying activity D by 10 days, then activity D would start on 12th day, 10 plus 2, 12, and it would finish on 15th day. So in this case we are delaying activity I. So it is not the part of free float. So free float would be total float minus head slack. Total float is 9 days and head slack is 1 day. So the difference would be equal to 8 days. So it is the free float for activity D. In a similar way, we can calculate the free floats for other activities as well. Suppose for activity G again, we are taking activity G. The total float is 5 days that we can calculate by finding the difference between latest finish and latest finish and earliest finish, or the difference between latest start and earliest start. So 16 minus 11, it would be equal to 5. So total float for activity G is 5 days minus the head slack. So head slack for activity G is 16 minus 15, that is 1. So 5 minus 1, it would be equal to 4. So 4 days would be free time available for activity G. So in similar way, we can calculate free floats for other activities as well. Now we will discuss about the third type of float, that is interfering float. It is that part of total float of an activity which affects the float of the following activities. Unlike free float, this float affects the following activities. In other words, we can say that interfering float of an activity depicts that part of total float which causes changes or reduction in float of the succeeding activities or the following activities. So interfering float is that part of the total float which affects or reduces the float of the succeeding activity. So it can be calculated by using this expression, that is latest finish time of the activity of the current activity minus earliest starting time of the subsequent activity. So we need to calculate the latest finish of the given activity, and out of that we need to reduce the earliest starting time of the subsequent or following activity. So let's have an example to understand the concept of interfering float. So let's again take the example of activity D, and we want to calculate the interfering float for this particular activity. So by applying this formula, latest finish time of the activity, so latest finish for activity D is 14, and earliest starting time for the subsequent activity. Remember, activity I is the subsequent activity of D. Its earliest time is 13. So the interfering float for activity D would be equal to 14 minus 13, that is equal to 1. So total float available with activity D is 9 days. Out of 9, free float is equal to 8 days, and the remaining 1 day would be the interfering float for activity D. In a similar way, we can calculate the interfering float for activity G. For activity G, the latest finish is 16, and K is the subsequent activity of activity G, and its earliest start is 15. So again, the interfering float for activity G would be equal to 16 minus 15, that is 1. In a similar manner, we can calculate the interfering float for activity I. The latest finish for activity I is 16, and for the subsequent activity the earliest start is 15. So again, the interfering float for activity I would be equal to 16 minus 15, that is equal to 1. So in this way we can calculate interfering floats for other activities as well. Now we will discuss about the fourth type of float, that is independent float. Independent float represents the amount of free time or float that can be used without affecting either the tail or the head events for a particular activity. In other words, we can say that independent float is that part of total float which causes no changes in floats of former or subsequent activities. That means previous activity may be completed in latest finish time, and succeeding activity may be started at its earliest time. So independent float is not going to affect either the succeeding activity or the former activity. It can be calculated by using the following expression, that is earliest starting time for the following activity minus the latest finish for the preceding activity, and minus the duration of the current activity. So by using this expression we can find the independent float for a particular activity. Further, there is second expression that we can use, that is free float minus tail slack, or further it can be expanded as total float for that particular activity minus head slack minus tail slack. So head slack is calculated for the succeeding activity and tail slack is calculated for the preceding activity. So by reducing these two slacks from the total float, we can find the independent float for a particular activity. So to understand the concept of independent float, let's go on this network. So we can use either of the expressions to calculate the independent float for any of the activities given here. Suppose we want to calculate the independent float for activity G. For if we use the first expression, that is this one, the earliest starting time for the following activity. So K is the following activity and the earliest starting time for K is 15. The latest finish time for the preceding activity. So B is the preceding activity of G and latest finish of activity B is 7 minus duration of the current activity. So 4 is the duration of activity G. So by using this expression we can calculate the independent float for activity G. So the answer would be 15 minus 7 minus 4, that would be equal to 4. So 4 is the independent float for activity G. By using the second expression we can also calculate the independent float for activity G, that is total float minus head slack minus tail slack. So total float for activity G is 16 minus 11, that is 5. Head slack means the slack time for the succeeding activity, that is K. It can be calculated by finding the difference between earliest start and latest start, that is 16 minus 15, 1, or the difference between latest finish or earliest finish, that is 22 minus 21, it would be equal to 1. So head slack is equal to 1. And tail slack, the tail activity or the preceding activity for G is B. So the tail slack would be equal to 7 minus 7, again it would be equal to 0, or 0 minus 0, 0. So by using this expression as well we can calculate the independent float for activity G, that is 5 minus 1 minus 0, that is equal to 4. Similarly, we can calculate the independent float for other activities, like for activity D. For activity D, the earliest starting time for following activity is I for D. So earliest starting time is 13. Latest finish time for the preceding activity, that is activity A. So latest finish is 11 and duration is 3. So in this case the answer would be equal to 13 minus 11 minus 3. So that would be equal to minus 1. We can use the other expression as well to calculate the independent float, that is total float minus head slack minus tail slack. So total float for activity D is 14 minus 5, that is 9, or 11 minus 2, that is 9. So 9 minus the head slack. So for head slack would be 14 minus 13 or 16 minus 15, that is equal to 1. And tail slack would be equal to 11 minus 2 or 9 minus 0. So it would be 9. So total float is 9 minus head slack, that is equal to 1, and tail slack, it is equal to 9. So the answer would be, so the value of this expression would be equal to minus 1. Always remember that if independent float for a particular activity comes in negative terms or in negative values, then we would consider the independent float as 0 for that particular activity. So for activity D, independent float is not minus 1, it would be considered as 0. So always remember that if the value is in negative terms or in negative values, then independent float for the particular activity would be considered as considered as 0. So the independent float for activity D would be equal to 0. So in this way we have calculated different floats for a network. Always remember that total float represents the total free time available with a particular activity. Free float represents that part of total free time that does not affect the succeeding activity. Third, that is interfering float represents that part of total free time or total float that affects the floats or time available with succeeding activity. And the independent float represents that part of free time that does not affect the succeeding as well as the preceding activity, or the floats of succeeding as well as of preceding activities. So in this way we can calculate different floats for a given network, which would be very helpful in managing a given project and would help in scheduling or sequencing of different activities in a given project. Thank you.